We have oxygen. Okay, I'm going into here. Let's stick this in here. What do we expect to happen?
Freeze.
It should shrink. Freeze. Why?
Because it...
Say louder. It's negative 300, but why is that relevant? Why would it shrink because of that?
Because it's tough.
Because the oxygen that we just blowed in here, right?
Yeah.
It's a gas. But when we put it to such a cold temperature, a gas goes to what when it gets cooled down? A liquid. Right. So it's slowing down everything that's in there. So that's what's happened. When we pull it back out, we should expect it to, what, expand, right? Because now it's speeding back up. The oxygen molecules are speeding back up because they're not touching the liquid anymore. See that? Isn't that kind of cool? We just literally slowed down gas. I think that's awesome. So, thank you for your assistance. Now, there's another couple cool things you can do with liquid nitrogen. Now, by the way, we should always be safe when we're doing science. We have goggles nearby. They're there. We're safe. Yeah. Good? Everybody's safe? Yeah, all right. So, anybody ever cook? Have you ever cooked anything? Help anybody cook anything? Yeah, all right. So, when you put a pan on the stove, and you put some oil in the pan and turn the pan on really, really, really hot, what happens to the oil? It starts popping things like that, but it turns into bubbles, right? It starts going all over the pan. Okay, that effect is called the Leidenfrost effect. Okay, and what it does is it creates a barrier between the surface of the pan and the oil, so where it's almost not touching it, it's kind of just like floating all over the place. And if you have something similar to that, where there's a really big difference in temperature, that's what happens. So that's exactly what's going to happen if I take this liquid nitrogen and pour it on my skin. If I pour this right on my arm, as long as it doesn't get caught in my arm hair, it should just slide right off, and I wouldn't even burn. So does somebody want to try that? You want me to show you first? Somebody want to volunteer? You want to volunteer? Come on. Come on, her. Are you filming this?
Yeah.
That's fine. That's fine.
So you gonna burn that?
No, I'm not. I'm going to ask you to put your hand like this and open your fingers, because if you have it like this, you might touch it there in the middle, right here, and that's not what we want. Okay, there's a hole in here. Relax. I wouldn't do this. This is science. You want safety goggles for fun?
No.
All right. You all right? All right.
I want to try that.
Yeah, it's okay.
You want to film me when I try it?
See, I wasn't that scared. Are you going to scream?
No.
Thank you.
Nothing.
Does it burn? No. All right, good. So what is that called? Leidenfrost effect. Very good. We want it without a ring, so you're fine. You're fine. I'm not going to there. It's dry. It's like cold. It is cold, but it evaporates. So like I said, this room temperature is the boiling point for liquid nitrogen. So it's evaporating. So it touches your skin, the Leidenfrost effect, and then it gets the carpet and evaporates. Does anybody else want to try it? We have some more in here.
It doesn't hurt.
Hey, come over here. You guys come over here.
That was fun.
Screamer.
I did. I got something.
Come on. So why don't you put all your hands here in the middle to make a circle? Try to
So
get
if you would
them
have
all.
rested your hand in that, would it like then burn or?
Yeah.
Oh.
Yeah. Did it hurt anybody? No. You're the only weird one. All right. So that's called, again, the Leidenfrost effect. Okay. You can go home and teach that to your parents. Yeah.
I play with liquid.
So put oil on the pan. Do you ever want to put the meat in the pot when the oil's doing that?
No, I don't know.
Oh, it's too hot. All right. So you've noticed now that we've learned a couple of things. One, obviously, safety purposes. We never want to put this in a sealed container. Two, when we put oxygen in a balloon and stick it in there, it starts slowing down those molecules, which is why that balloon shrunk. And then we learned about the Leidenfrost effect. Right. Now, so when it comes to liquid nitrogen, I bring this up in physics because it slows things down. Is it easier to observe something when it's going really, really fast or really, really slow?
Really
Slow.
Really slow, right. So when it comes to physics and we do experiments, we use liquid nitrogen to slow things down so that we can see what's happening more accurately. All right. So that's one of the physics purposes. The other great use of liquid nitrogen is ice. Anybody else agree? Yeah. All right, good. So we're going to make some ice.